All right, so we're going to look at 11-2, which talks about nets and surface area. We're getting ready to do surface area and volume. So there's a couple of ways that you could do surface area. There's some harder ways and some easier ways. You've got some formulas for surface area on your Ames reference sheet. Those formulas are derived from the nets. So a net comes from the three-dimensional solid. So here's your three-dimensional solid. So we've entered the world of 3D. So this is a pyramid, and it's a triangular pyramid because the base of this pyramid is a triangle. There's all kinds of different pyramids. There could be square pyramids, pentagonal pyramids, whatever the base is that that pyramid is sitting on. Pyramids always come to a point. The base is how we name it. And so all they've done is taken this point at C, and they've cut here, they've cut here, and they've cut here, and then they've laid it open, kind of like opening a flower. And so this is the net, and the net shows all four faces on that solid. And in this particular net, all four faces happen to be triangles. And so one of the questions they're going to ask you is to name all the faces. When you name a polygon, you always name it by its vertices, and we go in clockwise or counterclockwise direction. So if you named triangle ABC, triangle BCA, it's not going to make any difference, it's the same face. So here are the different four faces, all named. Every face but one has a C in it. You get that, Chase? I'll get you a calculator in a minute. All right, so then I want you to go ahead and copy this down. And your dot paper is going to be your graph paper. So whenever they use square dot paper, you can use regular graph paper in place of it. When they ask for isometric graph paper, so this one says use rectangular dot paper, which is square dot paper, to draw a net for the solid. Then find the surface area. So the triangular faces are 3, 4, 5 right triangles, and the other faces are 7 by 5, 7 by 3, and 7 by 4 rectangles. And here's your figure. So what you need to do is tear it apart and figure out what are all the shapes of the faces. And not every net is going to look the same. But you do have to be careful where you put the bases of the net. Like on this particular prism, these are the bases. Not because it's sitting on them, but because they are the parallel faces. These are the only two parallel faces on that prism. And there's a difference between a prism and a pyramid. Pyramids, all the faces but one come to a point, like here. Right there. Whereas on the pyramid, all the faces do not come to a single point. Rather, you have two parallel faces. So what shapes are these bases? Triangles. And then you've got these other faces that are going around the triangles. What shape are they? All three of them are rectangles, even though this looks like a parallelogram here, and so does that, because it's drawn on two-dimensional paper. All three of those faces coming off the triangular bases are rectangles. And in fact, there's your 3D triangular prism. You can see that all those faces are rectangles. And then here's the base triangle. All right, so you're going to draw. Here's an example of the net. Let's do it. So your bases should always be directly opposite of each other. So on your graph paper, it's impossible to draw this without graph paper, which is why you're supposed to have graph paper. Don't turn in your homework tonight without it being on graph paper or dot paper, one of the two, which are both on my website underneath the worksheet tab. So they told you that the triangular faces are 3, 4, 5 triangles. So here's, obviously the 5 must be the hypotenuse. So your legs are 3 and 4. And we know they're right triangles because it says so here. So here I've drawn a right triangle with a length of 4 and a length of 3. And then its other face is going to be parallel to it, losing my voice, or directly opposite from it. And it's really a reflection. So if we took this and reflected it over here, you have the same triangle. Then it goes on to tell you that you've got 3 different rectangular faces. Each of the rectangular faces has the same number 7 in it, but then they have a 5, a 3, and a 4. Where does the 5, the 3, and the 4 come from? From the triangle, right? Because as you see here, each of the rectangles surrounds that triangle. So each of the rectangles are going to have a dimension from the triangle. And so if you happen to draw where the length of 3 was here, then you have to have a rectangle that has a length of 3 attached to it. And so you've got 7 this way and 3 this way. So this is your 3 by 7 rectangle. And then your other 2 rectangles you can have top and bottom. It doesn't matter which is which, but actually it does matter which is which, doesn't it? If this is your 4 side of the triangle, won't these 2 sides come together right here when you fold it? So if this is 4, this needs to be 4. If this is 5, which if that's the hypotenuse, it should come out to be 5, this should be the 5, because these 2 are going to touch each other when it folds back together. Could you have drawn that net separately? Absolutely. Then it goes on to say that you have to find the surface area. So the surface area is the area of all the faces added together. So what's the area of this face? This is what by what? 4 by 7. So isn't this 28 units squared? And then this is what by what? 3 by 7. So isn't this 21 units squared? And what's this? What by what? 5 by 7. And so this is 35 units squared. How are you going to find the area of the triangles? What's the formula? 1/2 base times height. The legs in a right triangle 100% of the time are your base and your height of that triangle. So I've got a 3 by 4. What's 3 times 4? 12 and half of that. So this is 6 units squared. 6 units squared because they're both the same. Now how do you find total surface area? Add them all together. So 8, 9, 9 and 5 is 14, carry your 1, 2, 4, 4 and 3 is 7, plus the 1 is 8, and then 6 and 6 is 12. Don't we get 96 units squared for total surface area? Fortunately, we're going to come up with a formula where you won't have to separate out all the faces. And you can just look at various dimensions on that prism. But for now, we're going to look at some faces separated. And then that's how we got the area there. All right, so then if you would look at, for me please, your study guide that I handed to you, which is this here. Let's look at a couple of questions. So you're going to find surface area of various solids. This is a rectangular prism, triangular pyramid. This is a hexagonal prism, even though they're calling it solid. We're going to use its proper name later. So look at A, B, and C, and look at this net. What's the net made of? What kind of shapes? Appears to be all squares, right? There's no rectangles in there at all. So would this be the proper net to go with that solid? No, because that's a rectangular solid. What about this one? What does this have that the net doesn't have? Triangles. So this is a cube, right? So the cube can be the only one that matches up with that. So for some of you, this is going to be hard. Because if you can't take this three-dimensional solid and tear it down to all of its pieces, and some of you don't understand why that's difficult because you just see it. But then there's many of you out there that's like, I don't get that. Especially when we do the next thing. Or actually the third thing. So let's look at questions 1, 2, and 3. So identify the number and type of polygons that are on the faces of each polyhedron. Solids are called polyhedrons. The easiest way is to identify your bases, especially if it's a prism, and then you can count the sides on your bases and then add 2 more faces because your bases, there's always 2 parallel bases. So aren't these the parallel bases right here? This one and this one? I'm always going to look for the 2 faces that are parallel to each other. What kind of shapes are those? Pentagons. So first of all, this is a pentagonal prism. I want you to start to learn the proper names. And then all the faces that I don't have highlighted, what shapes are those? They're rectangles. And so I've got 2 pentagons. How many sides does a pentagon have? 5. So that means that there are 5 rectangles going around because 1 rectangle for each of these sides. And so then I have 5 rectangles. The rectangles are called your lateral area. Lat meaning fat. If I truly set that solid on its base, wouldn't it be sitting on its pentagon? And so the pentagons would be vertical to each other, correct? And so all the rectangles that are going around those faces, if I asked you to measure your fatness, let's say, wouldn't you measure around your waist, typically? And so think of lateral area as fat going around your waist, and your head and your feet are the bases of you. Because you're going to be asked to do that also. What shape is this? What's this polyhedron called? What's its base? A rectangle. What kind of thing is it? Is it a prism or is it a pyramid? Pyramid. So this is a rectangular. I'll use a different color. Pyramid. What's its base? That rectangle. Now pyramids are different than prisms. The faces that go around the base of a pyramid are what shape? Because this is my base. What shape is this right here? A triangle. That means that all the faces that go around that base are triangles. So how many sides on the rectangle? 4. So that means I have 4 triangles. This is a fun polyhedron. It's actually 2 pyramids pasted together, correct? So we really don't have a base, but if I cut it in half right through here, wouldn't that be my base of each pyramid? Now it doesn't count as a face for surface area because surface area is only what you can touch on the outside. So it's two triangular pyramids put together. So if the original base is a triangle, how many faces are going around that base? 3. So I have 3 here and 3 there. So I have 6 total triangles. So that, I think most of you can do. This part's going to be difficult for some of you. And with my eye issues, I get stuck on it once in a while. So you're going to copy the net. So they're going to give you this in your homework. You're going to have to copy the net. So they might give you a partial net. And you have to label all of the vertices appropriately. And oftentimes they're going to give you 1 or 2 vertices in order to get you started. And so here we've got CB. From here to here is CB. So typically what I will do is I'll go over here and go, oh, there's CB. CB is associated with, it looks like we have squares for bases, right? And then we have 4 rectangles. So this must be a square pyramid or a square prism, right? Doesn't that mean that this is the square base right there? So if this is CB, what goes directly this way from B? A. And what goes directly this way from C? D. Now, don't these 2 sides paste together right here? Shouldn't they be the same length? They're going to come together. If you fold this up, these are going to come together and touch each other. So what point is this? It's also D. You're going to have some doubles in here. If this is D, these 2 sides are going to paste together, and that's also going to be D. So this line from here to here goes from C to D this way, right? And then that means that, what's this point here? Because these 2 are going to come together and touch each other, so that's A. So then from here to here, from BA, that's BA. So, if I turn this and flipped it this way, right, if I took this and flipped it up straight up like this, what's going straight up from C? Straight directly up from C, what point is that? G. So that means that this point here must be G. Straight up from C. So that means that straight up from B would be what? F. So now GF is right here. See how CB and GF are parallel to each other. That belongs to this other base up here, right? So there's your square base. So then what's here? This is GF. And mind you that GF, this little square is coming up over here to the top and going straight up here. So if this is GF, HE is over here, going straight up from G, wouldn't that be H? And straight up from F, wouldn't that be E? Because I have to get other points. What point is here? These 2 come together. H. These 2 come together. What point is that? E. Now what do you know about these 2 points? Won't they eventually touch each other? Because this is going to wrap all the way around and come touch here. So if this is E, isn't this E here also? And if this is A, isn't this A here also? Did we miss any points? And some of you are like, that wasn't hard at all. But others of you are like, oh, that's hard, right? You have to think about it. It's easy to get switched around. All right, so look at the next one's a little bit more difficult. These are obviously your bases, and it must be another prism since these are all rectangles. What kind of bases are those? What shape are they? They're what? Trapezoids. So this is a trapezoidal prism. Great name. So they've given you M and N here. So M and N. And M and N. So this right here has been pulled out this way. It's like this flap has been pulled out and up, and then they just flattened that prism. So if this is MN, going straight that direction, what's this here? Q. And going straight here, what's this one? P. And then the next step should be, so I usually will find my base, all four, or however many vertices there are on my base, and then start putting the things that touch each other together. So these two sides are going to touch each other. So this is an M, and these two sides are going to touch each other. So this is an N. And what do you know about these points? Based on the last one. Well, they touch each other. And so this is M also. So we have the whole left side. You find the right side. See how you do. Share it with those around you and see if they get the same thing as you. Some of you are done immediately. Others are still thinking, which is okay. It's normal. Just share it. All right, so for those of you still stuck, all you have to do is look at this flap here. Right, that's pulled up. Here's your Q and P here, here's your Q and P here. Directly across from Q to get to the next base is what? V. So directly across from Q here, this is V. And directly across from P here is T. Because I'm looking for these points right here on my other base. That means I'm going to go down from V this way to get to P, so P is here, and down from T here to get to S. The more of these you do, the better you get at them. These are supremely difficult for me to do personally. My brain doesn't work the way normal people's do, especially my eyes. Oh, it's an R, sorry. Oh, the P, yeah, is an R. Thank you, you're right. So this P belongs, oh, that P's there. Sorry, my mistake. All right, so we got the R, and then these touch, right? And then these touch. So this is S. What's this one? R, because those touch. So once you get used to it, it's not so bad. But you've got to find the bases first. The bases are going to help you find this lateral area. So this is your lateral area. These are your bases. Okay, so that's 11-2.